Good day and welcome to the second part of financial decisions. Today we're going to expound on the investing decisions, which are divided into the capital budgeting decisions and the working capital decisions. First, let's start with capital budgeting. Capital budgeting is used to evaluate major projects and investment to estimate the project's prospective cash inflows and outflows to determine the potential returns. Capital budgeting assesses whether or not project, a business venture, or a purchase of a heavy machinery will be worth its price. It estimates whether we can get our money's worth. Capital budgeting has several techniques to find out whether or not a project is viable or profitable. We have the payback period, the net present value, the internal rate of return, and the profitability index. But before we go into the specifics of each of these techniques, we need to figure out the basics, and that is the future value of money and the present value of money. The future value of money is the value of an asset at a specified time into the future, assuming interest rates or rate of return. It is computed as the future value is equal to the present value multiplied by 1 plus the opportunity cost raised to the number of years. So an example is, if I were to put 500,000 into a savings account today and it will yield 3% per annum, how much money will I have after 7 years? We substitute the values into their respective places. So FB is equal to 500,000 times the product of the 1 plus 0.03 to the 7th power, which is 1.23. It will yield us a 615,000. So 615,000 will be the value of the 500,000 7 years from today if we put it in the bank, if it will yield 3% per annum. Next one is the present value of money. The present value of money is the current value of a stream of cash flow given a specified rate of return. So the present value of money calculates how much the money is worth today. The values that we get are often projected values into the future. This considers the discount rates and the opportunity cost. Therefore, regarding the time value of money, the present value is computed as future value times 1 divided by 1 plus the opportunity cost raised to the number of years. So let's put it into a concrete example. Mr. Montoya wants to retire with 1 million in 15 years. If his bank will give him a 5% per annum interest, how much money should he save right now? So we substitute the values into their respective places. 1 million is the future value that we want. 1 over 1 plus 0.05, that is the opportunity cost or the interest rate, raised to 15, which is the 15 years. So 1 million times 1 over 2.079, that is the value of the 1 plus 0.05 raised to the 15th power. And then we result with 1 million times 0.481. So 1 million times 0.481 is equal to 481,000. If we want to have 1 million in 15 years, we need to save 481,000 right now and put it in the bank. That is the implication of the present value of money. Now that we discussed the present value of money and the future value of money, we could now go into the specifics of each of the capital budgeting techniques. We start with the net present value. The net present value is computed as the present value of inflows less the total investment outflow. The net present value predicts the future cash flows, and for a project to be accepted, the net present value should be greater than 0. The ruling is the higher the net present value, the better it is. So to calculate the net present value, first we determine the values, the opportunity cost, the interest rate or the interest rates, the projected yearly cash inflows of the investment, and the number of years. Number 2, we calculate the present value of the cash inflows. Number 3, we add the present values. Number 4, we subtract the total cost of the investment to the sum of all the present values of the cash inflows. So let's put that into a concrete problem. What is the net present value of the 600,000 investment with cash inflows of 130,000 from year 1, 300,000 from year 2, and 310,000 from year 3, and an opportunity cost of 5% per annum? So number one, we gather the values. The total investment is 600,000. Our opportunity cost is 5% per annum. Our cash inflows per year is 130,000, 300,000, and 310,000 for year 1, year 2, and year 3, respectively. Number 2, we calculate the present value of the yearly inflows using the formula that was given here. The present value is equal to the future value times 1 over the 1 plus the opportunity cost raised to the number of years. So we computed it as the future value of year 1, 130,000, and the present value is 123,760. Year 2 yielded a present value of 276,100. Year 3 yielded a present value of 267,840. Number 3 is we total the present values. So we total 123,760 plus 272,100 plus 267,840. It totals to 663,700. So number 4, we deduct the total investment cost and the total of present value. So the net present value is 663,700 less 600. So we get the difference and we have 63,700. That now is your net present value. Now we go into deciding whether this investment is financially viable. Since the ruling is, if NPV is greater than 0, then the investment is financially viable, meaning it will give us money. So since the NPV is greater than 0 and it's 63,700, the investment, the project, is considered as financially viable. If it happens that a decision must be made between different projects, the investment proposal with a higher net present value will be selected. Next, we discuss the internal rate of return. The internal rate of return is an estimation of the future annual rate of growth and return rate of the investment. The internal rate of the return is the opportunity cost when the net present value is 0. And the higher the internal rate of return, the more desirable the project. So we compute it. The steps in figuring out the internal rate of return is number 1, calculate the investment's net present value. Number 2, experiment with different rates of opportunity cost until the NPV becomes 0. Number 3, the opportunity cost when the NPV is 0 is the internal rate of return. So we calculate the internal rate of return by calculating first the net present value and experimenting with different opportunity cost. And when the opportunity cost we inputted made the net present value 0, that is our internal rate of return. So we will still be using the previous problem. When we use an opportunity cost at 8% per annum, we reached a net present value of 23,660. We need it to be 0. So 8% is not the answer. Next, we tried it at 9%. At 9%, it reached the 11,146.93. Still not 0. So we try it at 10%. At 10%, it yielded a negative 976.71, meaning whatever the opportunity cost that we're looking for is in between 9 and 10. Since we cannot put 10%, we have to experiment with the 9s. And we have found out, after the experimenting, the calculating of the different values in between 9% and 10%, we arrived at exactly 9.918264 and gave us a 0 of net present value. And that is our internal rate of return. So again, the internal rate of return is your opportunity cost. The opportunity cost when the net present value becomes 0. And the net present value became 0 at exactly 9.918264% opportunity cost. And that is your internal rate of return. So how do we decide? Investment proposals with a higher IRR will be selected. If there are several investment projects that are being pitched, the higher the IRR of your project, the better it is, the better chances for your proposal to be financed. Next, we discuss the profitability index. The profitability index is just a ratio of the payoff to investment of a proposed investment. So we just divide the net present value with the total investment cost. Because it's a ratio, the profitability index is never negative. So following the original example, with the net present value at 663,708.02 divided by 600,000, our profitability index is 1.11. The ruling is if the profitability is greater than 1, then it is financially viable. If the profitability index is less than 1, then we reject it. It's not financially viable. And if the profitability index is equal to 1, it means that we're at the break-even point. We earned nothing and we lost nothing. So we're basically indifferent. The higher the profitability index, the better it is for your project to be financed. Last, we have the payback period. The payback period is just the length of time until the investment reaches a break-even point. Shorter paybacks mean more attractive investments, and more attractive investment means it could be financed better. And in here, it is optional to use the present value. We could use the present value and we could use just the actual values without the time factor. First type under this is the even cash flows. Even cash flows meaning every single year it gives you the same output of cash inflow. So every year it's equal. So we will use the formula payback period is equal to initial investment over the annual cash flow. Let's say that we gave a 600,000 investment and the annual cash flow is 125,000. So 600,000 divided by 125,000, the payback period is 4.8 years. And for uneven cash flows, this is when we gather different values for every year. So first year we have 130,000, second year we have 300,000, third year we have 310,000. Unlike in even cash flows where every year it's just 125,000, every year 200,000. Uneven cash flows means we need to do a different formula. So the payback period is computed as E plus B over C, where E is the year immediately preceding to the year of recovery, B is the amount to be recovered, and C is the cash inflow during the year of recovery. So we calculate the payback period for our problem beforehand. So 600,000, 130,000 for year 1, 300,000 for year 2, 310 for year 3, 450 for year 4. Steps is number 1, we compute the cumulative cash flows, meaning it totals every year. It adds every year. Number 2, we determine the year of final recovery. Number 3, we determine how much investment is left to be recovered. And number 4, we apply the values to our formula. So number 1, we made a cumulative cash flow. This is a cumulative cash flow. Itself adds 600,000 being our investment, 130,000 for year 1, 300,000 for year 2, 310 year 3, 450 for year 4. The preceding year prior to our recovery, the year of recovery is year 3. It means it's the year where we finally get our return of investment. So we get that. Before that, we need the preceding year of prior recovery. So year 2. We need that as well. And then we need the amount to recover, which is 170,000. So we put that into the formula. 2 is the number of years before the year of recovery. 170,000 is how much money we need to recover for us to have a return of investment, and 350,000 is the projected cash flows for the year. So payback period 2 plus 0.49, 0.49 being the product of 170,000 divided by 350,000, the quotient rather. So payback period is 2.49. It will take 2.49 years before we have a return of investment. So the project with the lower payback period will be selected if there are other projects to contend with. Next, we discuss how the management makes its decisions on capital budgeting. We have 3. We have the mutually exclusive projects, we have the accept and reject decisions, and we have the capital rationing decisions. For the mutually exclusive projects, it means that the company only has room for one project. So there will be a lot of projects, and all of them could be viable, all of them could have been accepted, all of them will have yield profits, but only the best one will be selected. Only one viable project. That is how they decide. So the top project, that is what they're going to get in mutually exclusive projects and mutually exclusive decisions. Number 2, we have the accept reject decisions. Accept reject decisions is just the acceptance rule. If they pass the profitability or the viability test, they will be funded. Last one is the capital rationing decisions. In the capital rationing decisions, it means that they don't have that much money, that much finance. So their investments must be prioritized. Whatever investments is needed by the company, like right now, that will be prioritized and it will be financed.